Hey guys, Andre Freeman here. So I want to go through a problem in section 2.2 related to constructing linear models from a graph. And really we mean linear equations. The key that we mentioned and looked at before is that we need the slope, which is the constant rate of change for the linear function, and we also need the y-intercept, which is the initial value. In this problem, we're given 2 points, but we don't have the slope. We also don't have the vertical intercept or the initial value. So let's take a look. We can begin by recognizing that we have a couple ordered pairs, so we can set up a table in the form t and then p of t. Note that these are the variables that are provided in the on the graph, and t, this would be the input variable, which is the independent variable, and p of t is the output variable, which would be the dependent variable. Okay, so with that, we can proceed to analyze the situation. Okay, so we have 2 and then 4.58 and 3 and 4.28. Let's just interpret the first data point real quickly. This first ordered pair is saying 2. That means 2 years since 2012, which is the year 2014. The population is 4.58. Now this actually is in thousands. This is I copied this from the workbook. This is the population in thousands. So we really can interpret this first ordered pair to say as follows. The interpretation is that in 2014, the population is 4.58 thousand, which would be 4,580 people. So you want to take the time to interpret the ordered pairs before doing any kind of analysis on them. All right, so the model. The linear model is going to be of the form p of t, because that's the output variable over here. P of t is equal to m times t plus b. T is the input variable. And we're going to find m and b. We're going to find m and b from the data points. Let's first find m. To find m, we're going to use the slope formula given these 2 data points. So m, which is the slope, this is the constant rate of change. And we talked about this. The constant rate of change is the ratio of the change in the output divided by the change in the input. So this is change in output divided by the change in the input. And we can get this ratio directly from the ordered pairs or from the table. So let's do it. So we'll say m is equal to the change in the output. Now the other way that we can do this, and actually before I plug things in, we can think of this as saying y2 minus y1 divided by x2 minus x1 in the context of 2 points, x1, y1 and x2, y2. So let's call this first point x1, y1. Let's call this second point x2, y2. So now we basically have values for this formula. Again, y2 minus y1 is going to be the change in the output values, which in this case would be 4.28 minus 4.58. And the change in the input is going to be the change in these x values, or t values, which is 5 minus 2. This simplifies to negative 0.3 divided by 3. And when we do it out, we end up getting m is equal to negative 0.1. The units here would be thousands of dollars per year. T is in years. But for now, let's not focus on that. Let's just kind of focus on getting the equation. So we have m. So the next step in the process is we're going to now find b. To find b, we're going to use the equation that we're provided here. So let's go back to the model. The model is p of t is equal to m times t plus b. We already know a couple of things. We know the value of m. We know that m is equal to negative 0.01. And we can use one of these points here for values for t and p of t. Let's use that point. If we use this point to 4.58, we now have values as well for t and for p of t. So we're going to now plug in these three numbers into the model and solve for b. So the key idea is when we say solve for b, we're algebraically solving for b using the slope-intercept equation. Okay, so P of t is 4.58. I'm kind of shifting things over a little bit. That's P of t here equals m is negative 0.1. T is 2. And now we don't know the value of b. We're solving for b. So we replace P of t with 4.58. M with negative 0.1, T with 2, and we left B here, and we're going to solve for B. This simplifies to 4.58 equals negative 0.2 plus B. And when we add 2 to both sides, we end up with B is equal to 4.78. Make sure that makes sense to you. So this is now the initial value, which is also the y-intercept. So we would not have identified this number specifically from the graph because we know the y-intercept, the vertical intercept, is close to this, but we wouldn't, looking at this graph over here, we could not identify that this number is 4.78. So we had to algebraically solve for b. Well, now we have the numbers m and b to plug in to construct the equation. So the final step is to get the equation, and the equation will be, so P of t equals m, we know, is negative 0.1 times t, which is the input variable, and now plus b, well, b is 4.78. So this now becomes, let's get rid of this. This now becomes plus 4.78. All right, and we're done. So this is some work, guys, but it's very doable. We're looking to get a linear model or a linear equation that represents this relationship between the two variables, and we're all set. So remember, key steps: first, find m, the slope, then use this linear form. This linear form, by the way, is y equals mx plus b. But instead of using x and y, we're using t and p of t. And again, if you think about the big idea, we need to solve for b. So we're plugging in numbers for the input variable, for m, which we computed, and then of course for the output variable. And we have that from the point and the slope. All right, guys, I hope this helps.